Our names are Edward, Caetano, and Nalia, and we chose to do the vessel tracker project. And one of the reach components we did is that instead of using the randomized speed over ground variables that we made in the graph, we treated the latitude and longitude as x and y values, and we calculated the displacement from that just like manually, and then we used logical indexing along with the Pythagorean theorem to find the displacement.
Okay, so our vessel traffic system, it monitors basically virtual ships and they periodically send their positions. So we, as a reach component, we decided to include a position alarm. So this alarm is the same one that it's on the Bermuda Triangle, and once it reaches a certain position, such as in unwanted territories or something, it like lights up.
Yeah. Okay. And so getting into the code, the way we organized our project was we split each ship up into three different callbacks. And while this was helpful for organizing our code, the main drawback with this setup is that the app can't display multiple ships at the same time. But that's okay because it still functionally shows each ship. And then every button pressed, there's three buttons. They're essentially the same button. They run the same code. Each ship, the only difference is that the data for each ship is slightly different. Apart from that, the code is pretty much the same. And yeah, so the way we did that is we generated 3 Excel sheets and then hooked them up to MATLAB using the UI-GetFile function, and it calls the XLSX file. And yeah, so yeah, at the top back here, we specified our ThingSpeak channel identities. And then back here, we named this variable data so that we can call data from the Excel sheets later on using arrays for each column in the data in the Excel sheet. And okay, so when the Titanic button is pressed, we use logical indexing to increment each step for the change in position for the ships. And we did this and we plotted this position change using the geoscatter function. Yeah, so basically by inputting the latitude and longitude data from our Excel sheet into the geoscatter function, it plotted the ship's travel from, it was basically around like 20 points per ship. So 20 different longitude and latitude points. And this geo-base map part is basically making the map in the background color. And using the same indexing, we were able to come up with code for a speedometer, which we were able to, one of the reach components that we had was calculating the speed using the Pythagorean theorem. Right here, instead of just using generated data from an Excel sheet, we calculated the speed over the ground using the displacement, longitude and latitude, the Pythagorean theorem, and then put that into a string and displayed it using a speed label. And then using that same speed variable, we assigned the variable speed to that value of the speed that we calculated using longitude and latitude. And this is the code for our speedometer. As you can see, it will light up green when the speed is below 166 for the Titanic. And when it's over 166, it will turn red and display slow down. And on a similarly, our position alarm, which is another reach component we decided to have, will light up when the Titanic is at a point where the latitude is below the 24.45 and below the, well, that's for latitude, below the 79.5 longitude value. It will be green, and otherwise it will be red, and it'll read Bermuda Triangle. And here, this is just the pause between increments. This is our plot for the original, this table, the vessel voyage table. It plots it on the original window with the lamps, the speed and position lamps. And then this for loop right here basically connects our data from the Excel sheets to the ThingSpeak channel, which we have to pull up. I will connect that later. But yes, basically, I used the code from Mini Project 7 to create 6 ThingSpeak channels for each code column from the Excel sheets. One thing that I was unsuccessful with was I was not able to plot the variable speed that I calculated up here using the Pythagorean theorem onto ThingSpeak. That's one thing that I wish I could have done better on. But as you can see, it's for the Queen Anne, which is our second ship. It's the same exact code, and it executes the same way. And this is our third ship, Star Destroyer. And I'll just go ahead and show you how our app works right now. So when we click the Titanic button, it'll prompt us to pick a file, and we got to pick the Titanic data file. And then looking at our geoscatter plot, we can see how the ship moves according to the longitude and latitude values, and the speed lamps and position lamps change based on the data from the Excel file. All right, thank you.
Recording in progress.
Okay, so one thing that I forgot to show was how we connected our data through the Excel sheet through MATLAB onto ThingSpeak. And that's going on in this for loop right here, this one. And so I'm just going to run the code and show how it translates onto the ThingSpeak website. And so let me just pull up the app right here, and I'll click Load Star Destroyer Data and click Star Destroyer Data. And as we can see on the geoplot map, it's moving. It takes a while to upload to ThingSpeak. It's a little bit laggy because of the pauses. These pauses right here, they didn't allow me to increment the ThingSpeak, the pause between increments that get sent to ThingSpeak. We needed a higher, or like a better version of ThingSpeak to have the increments be shorter. But as you can see, the data is slowly but surely getting transferred onto ThingSpeak. Here's the private view, and this is the longitude versus time, latitude versus time, longitude versus time, MSSI. I'm not sure which, it could be wrong. And then, so we have a total of 6 graphs: width, length, and vessel type. And as you can see on the public view, this is available to everyone if you look at our channel ID. And this is the full graph of the longitude, latitude. All the other components stay constant. They're just constant values. But yeah. And that'll be it. Thanks for watching.